Chapter 10 Gases. Exercise 10.97. Chlorine gas reacts with fluorine gas to form chlorine trifluoride. Here's the chemical equation. A 2.35 liters reaction vessel, initially at 298 Kelvin, contains chlorine gas at a partial pressure of 337 millimeter mercury and fluorine 737 millimeter mercury. Part A. Identify the limiting reactant. We'll look at this reaction first. The ratio between chlorine 2 and fluorine 2 is 1 to 3. Now we look at the ratio of partial pressure. 337 versus 773. So we'll flip this too. And we get 2.2. So the ratio between chlorine and fluorine is only 2.2, less than 3. What does that mean? That means the fluorine gas is the limiting reactant. And why can we just use the ratio of partial pressure? Well, it's just because the fluorine gas and chlorine gas, they have the same volume and the same temperature. Therefore, the number of moles of chlorine is proportional to its partial pressure. The number of moles of fluorine is also proportional to the fluorine's partial pressure here. So this ratio is not only the ratio of partial pressures, it's also the ratio of the numbers of moles. And it's less than 1 to 3, that means fluorine 2 is the limiting reactant. Determine the theoretical yield of chlorine trifluoride in grams. We'll need this information. Given the volume, the temperature, and the partial pressure of fluorine, we can determine its number of moles. And then the number of moles times 2/3 would be the number of moles of this product, chlorine trifluoride. So let's do PV equals nRT again. N equals PV over RT, and we'll calculate the number of moles of fluorine. Pressure is 373. Volume is 2.35. R is 0.08206 in ATM liter over mole K. The temperature 298 Kelvin. Now we have the number of moles of fluorine gas, 0.093. But because 3 moles of F2 make only 2 moles of the product, so we need to multiply this by 2/3. Now this N is the number of moles of the product. Finally, the theoretical yield in grams. So we look up the molar mass of chlorine, we look up the molar mass of fluorine. Alright, and we have 3 fluorine atoms, and then we set up this equation. The final answer would be 5.74. Let's review this. This is pressure of fluorine, volume of fluorine, ideal gas constant, the temperature of fluorine. So this is the number of moles of the fluorine gas. But there's a 3 to 2 ratio between fluorine and chlorine fluoride, trifluoride. So we need to multiply the number of moles of the fluorine gas by 2/3. And now we have the number of moles of the product times the molar mass of the product. We get the theoretical yield of the product, 5.74.